experimental testing of combustion parameters and emissions of waste motor oil and its diesel mixtures. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. Thanks to all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share, and subscribe. Increasing energy consumption, strict emission standards, and consumption of oil resources have led a larger number of researchers to explore the possibility of using alternative fuels for internal combustion engines and heat generators. Waste oils present a serious problem for the environment due to their disposal and are considered useful energy sources due to their high calorific value. The production of hydrocarbon fuel from waste engine oil is an excellent way to produce alternative fuels. The aim of the research in this paper is obtaining fuel with a mixture of waste engine oil, or WMO, and diesel fuel that can be used as an alternative fuel for internal combustion engines and low-power heat generators. With this goal in mind, tests were conducted to estimate the combustion parameters and emission at low heat output of 40 kW. Waste motor oils, or WMO, and 4 of its diesel mixtures were used, varying in weight from 20% WMO and 50% WMO. Test results were analyzed and compared with diesel fuel. Higher NO, CO, and CO2 emissions were determined for WMO and its mixtures compared to diesel fuel. The flue gas temperature in the kiln was high for all WMO and diesel blends, which indicates the efficiency of the output energy. The absorption of the flue gases in the scrubber with distilled water showed higher presence of sulfates, sulfides, nitrates, and nitrites compared to allowable values. In conclusion, it is that WMO and its mixtures with diesel fuel can be used as an alternative fuel in different mass ratios in internal combustion engines as well as in various low-heat power combustion plants. Taking into account particularly low fuel consumption values obtained from the WMO diesel fuel ratio, this compared a significant value and reduces additional costs.